Now that we've spoke about the derivative function and we did some differentiation from first principles, let's discuss briefly the mean value theorem. Now, what it says is that if you have a function, some curve between point A and point B, and you join those 2 points using a secant. Remember that if the x value is A, then you'll have f at A on the y-axis, and you'll have f at B, this is B, in the y-axis. Now, it says that if these two conditions hold, now between A and B inclusive, your function is continuous, and also between A and B, your function is differentiable. Now, by continuous, we mean that at any point of your function between A and B, there are no breakout. Your function is continuous throughout between those 2 points, and including the points themselves. Now, between A and B, your function must be differentiable. That is supposing that there are no sharp turns in your function, so it's just nicely curved. Then there exists a point C, whereby the gradient at that point, the tangent at that point, visualizing the gradient, is parallel to the secant. It's not perfect, but you get the idea. There exists a point between A and B if these two conditions hold, and we can find the gradient at that point, the derivative, by just taking the average rate of change between B and A. So here, our derivative function, we've always said that we are finding a gradient at a specific point. So f at A, we want the gradient at A. F at B, we want the gradient at B. So it gives you instantaneous rate of change. And we can find that instantaneous rate of change of C, given that these two conditions hold, by finding the average rate of change of these 2 points. Meaning that we are looking for the change in Y and the change in X. And how do we find those? By saying what's the change in Y. That will give us the Y value at B minus the Y value at A over the X value at B minus the X value at A. Now, to summarize, the mean value theorem says if you have 2 points A, B, a curve between points A, B, and you join them with a secant. A secant is a line that touches a curve at 2 points. Given that these two conditions hold, number one, between A and B inclusive, your function is continuous. So there are no breaks in your functions, no nothing. Number two, between A and B, your function is differentiable, meaning there are no sharp turns like this, no surprises. Then there exists a point C, whereby the gradient will be parallel to that secant, and you can find that instantaneous rate of change, that derivative at C, by finding the gradient between A and B, the rate of change between the average rate of change between A and B, and you do that by taking the change in Y over the change in X, meaning the Y value of B subtracted the Y value of A, the X value of B subtracting the X value of A.